Hello, this video is about the making process of one of the most famous items in the world called Pokeball. Hi, my name is Andrew Kim, and I am an undergraduate SUNY Korea mechanical engineering student. I will present my term project, making a real functioning Pokeball from prototype to mass production. My motivation came from Pokemon. Pokemon is a massive global market and also a subject that I love, so I wanted to make an object that comes from Pokemon. And my goal is to make not just a figure, but a fully functioning open and closing Pokeball. I started with the design using Fusion 360. To ensure the mechanism works, I designed the shells, the rings, and the internal buttons structure as separate parts for precise assembly. For the prototype, I used a Creality K1 Max 3D printer with PLA filaments. I combined the parts of the Pokeball into one STL file and printed it out. Since the size was decreased, the total printing time was also decreased than I thought, to approximately 35 minutes per one Pokeball. As you can see, I successfully printed the parts and combined them. However, after the 3D printing was done, I found out there was many parts to improve. First, the parts of the Pokeball were much more smaller than I thought, so it was hard to assemble the full Pokeball in my hands. And there was unavoidable external maintenance, such as super gluing to make the Pokeball. Due to the support making from the 3D printer, I also had to do some carving. Still, it became clear that 3D printing is great for design verification, but not suitable for mass production. It fits more as a small production plant. So for the massive production, I need to maximize the manufacturing efficiency, ensure the components' precision and durability, and reduce the cost per unit. Here's the optimized workflow. We are replacing slow 3D printing with mainly injection molding and die casting. We also introduce an automated robotic assembly and the automated vision inspector. This change drastically reduces the production time from 35 minutes to under 1 minute per unit. For the materials, we will switch from PLA filaments to ABS plastic. ABS is widely used in Lego and industrial products, providing much higher strength and impact resistance compared to the PLA filaments. We will use high-speed injection molding machines for the shells, buttons, and rings. For the hinge parts, we will use die casting to ensure the mechanism is durable enough to withstand repeated opening and closing. After the parts are made, the automated robots will assemble the parts into one and send it to the vision inspector to check the quality. For the injection molding and die casting, there has to be a high precision steel molds designed to make the parts of the Pokeball. Using EDM, which is electrical discharge machine, will make the molds for injection molding and die casting. Since EDM is able to make tiny details for small parts, high quality molds will be made. Also for the automatic robot assembly, it needs assembled jigs for the robots to assemble the parts. So for the quality control, we move away from manual checks to automated vision inspections. And this system instantly checks the dimensional tolerances and aesthetic defects. From a business perspective, I will set the price at 15,000 won per one Pokeball, which is competitive against existing products like Takara Tomy, shown in the pictures. To reach the break-even point, our target is to produce and sell at least 200,000 units annually. For the conclusion, I successfully verified that the open and close mechanism works perfectly through the 3D printing prototypes. To overcome the limitations of 3D printing, such as rough surfaces and slow speed, I transitioned the plan to injection molding and zinc die casting. This changed significantly reduces the production time while making the product much more precise and durable. To ensure profitability, I set the mass production target to 200,000 units per year, with a retail price of 15,000 won. We can secure a strong position in this market. Thank you so much for watching this process and have a good day.